Hey guys, welcome to Physics Help. My name is Brandon, and today we're going to be talking about statistical variance and standard deviation. So we're going to start off by defining what variance is. And the way I'm going to do this is by trying to lead you through a series of thoughts. So imagine that you're a scientist and you're conducting a series of measurements and you have data points and you calculate the mean and you notice that it has the same mean as another set of data points, but instead the data points are spread out for one experiment and very narrow for another experiment, meaning that they deviate from the mean a lot in one and not so much for the other. And you want to develop an expression or a number that represents how much these data points differ from the mean. So that's basically what we're trying to describe here, is a number that is very large when there's a lot of data points that are different from the mean, and very small when all the data points are very similar to the mean. So obviously when making these comparisons, the things that are similar in both experiments is that they have the same mean. In other words, it's more of a neutral aspect of it. It doesn't depend on the spread of the data points. So that's where we make our reference from when we're talking about how much do those data points differ in regards to a spread. So we define a deviation as being x minus the mean, or x minus the x with the pointy brackets. If you guys haven't seen the videos before, that's what the mean is, or how we're defining it here. It's just as an x with the pointy brackets. And it has different definitions depending on whether it's a discrete or continuous probability distribution. So when we have a data point and we're subtracting that value from the mean, that obviously gives us a number. It's very large when the data point is very far from the mean, and very small when the data point is very close to the mean. So this gives us the opportunity to sort of develop some kind of tactic to measure how far the data points are from the mean. Perhaps we can calculate all the deviations from the mean and average those deviations to develop a number or some kind of idea that tells us how far apart the data points are spread out. But here's the problem. The average value of all the deviations from the mean is 0. And this makes sense because it's the average value of all the data points. So half the time that deviation that we calculate, x minus the average, is going to be positive, and half the time it's going to be negative. So when we add up all those numbers, we get 0. So obviously our problem comes from adding up all the deviations because they're canceling out with each other. So we have two options. Rather, we can take the absolute value of it. So all of our deviations that we calculate are positive quantities. But the problem is absolute values can be challenging to work with at times. So instead, we take the average of all the deviations squared. And this is what we define as the variance. Mathematically, this is expressed as sigma sub x squared, which, as we said, is defined as the average of the square of x minus the mean. So as we mentioned in the beginning, we're trying to develop a number that describes how the data points are spreading out from the mean. Well, we developed the variance to help us understand this, but the problem is the variance takes the average of the deviation squared. So now we have a value that's squared that kind of reflects how the data points are spreading out. So in order to get a magnitude of how these data points are spreading out, a number that truly reflects how these data points are spreading out, then we take the square root of the variance. And this is known as the standard deviation. And you can kind of see this coming when we see that the variance is described as sigma sub x squared, because it's reflecting the fact that the quantity that we're taking the average of is a squared quantity. So to develop a true idea of how the data points are spreading out, we need to take the square root of that quantity. And that's why we're denoting the standard deviation as sigma sub x and not the variance as sigma sub x. So formally, we define this as sigma sub x is equal to the square root of the average of the deviation squared. So because we define the variance as the average of the deviation squared, we can FOIL out the deviations. And this leaves us with x squared minus 2 times the mean times x plus the mean squared. So now we're taking the average of a bunch of terms, and that's actually equal to the average of each term added together. Mathematically, this is expressed as the average of x squared plus the average of -2 times the mean times x plus the average of x squared. As if that wasn't confusing, but if you look at it, it makes sense. Math makes sense on paper, but when you're trying to describe the average of x squared, yeah, good luck. So I want to tell you guys something very important. Whenever we see x with the brackets around it, that's the mean, and the mean is a number, a constant, so it's allowed to come out of any other brackets that it's in because it doesn't change. As soon as x is surrounded by those brackets, we can treat it as any other constant. But x inside brackets can't come outside the brackets because that is a variable still, and we don't know what that is. So when we have the brackets with x squared as our first term shows, that can't change at all because we still don't know what the average value of x squared is. But we can change what our other term is, the -2 times the mean times x. The -2 is a constant, and so is the mean. So we can pull those out, and we're left with -2 times the mean times the mean. And lastly, we have the average of x squared, which is also just a number. So that can come out of the brackets as well. So it looks like that just disappears because we're literally just taking the average of a constant, which is equal to its constant. So with that being said, this is equal to the average of x squared minus 2 times the mean squared plus the mean. And if we combine like terms, then this is equal to the average of x squared minus the mean squared. And this is our final result. The variance, which we define as sigma sub x squared, is equal to the average of x squared minus the mean squared. So all we need to do is just calculate the average value of x and the average value of x squared in order to find the variance. So I also wanted to mention that the variance is also known as the second moment around the mean. And the reason why is because the variance is equal to the average of the deviations squared, or the average of the deviations raised to the second power. If we take the average of the deviations raised to the third power, this is known as the skewness. And if we take the average of the deviations raised to the fourth power, this is known as the kurtosis. We won't be going too much into detail about what these things mean because I feel like if I did, I would be getting off topic. But I did want to show you guys that these things do exist, and if you wanted to learn more about them, then you can look them up. And that's it. Today you guys learned about statistical variance and standard deviation, and we touched also a little bit on the moment about the mean, as well as how to calculate the variance in a little bit of a faster way. Thank you guys for watching my video, and please subscribe.